So welcome to today's webinar. It's about the compact drive technology. It's split in two blocks. First, we start with the AM8120 series, and later on I will describe some new features for our established EL, EG, and EP servo solution. So first, some organizational matters. So if you have questions, please use on the right side here, you see the question window. My colleague Marvin Düsterhaus from the product support tries to answer this parallel to the webinar. If there are any questions which are more general in nature, we will answer it directly after the webinar. Briefly to my person, my name is Lippe. I'm since 2003 with the company Backoff. I'm product manager in the I/O department and responsible for the compact drive technology. This includes all drive technologies in the safety extra low voltage range up to 48 volts. Besides servo technology, also steppers, DC and BLDC amplifiers. I would like to start with two foils regarding the current product groups for servo solutions up to 48 volts. We start with IP20 classic Ethernet terminals and EG plug-in modules. So it's for the protection class IP20. The DC link voltage range goes from 8 volt up to 48 volts. The output current, depending on the module which you use, is from 2.8 amps up to 8 amps. Which are more or less around about 500 watt output power. We have an integrated travel distance control called DMC. Feedback is via the OCT, so one cable technology. You can connect single turn or multi-turn encoders, motors. There are additional IOs part of these modules, so two additional digital inputs, which you can use, for example, as limit switches or for latching the position, and one digital output for the brake if it's necessary. And on those terminals, you have the possibility to order it with an optional safety STO input. The third design is the EP design. It's for the protection class IP67. So to realize that, the electronic housing is potted. It's for applications, for example, without control cabinets. The DC link voltage is the same range as you saw it for the EP20 module, so from 8 up to 48 volts. Output current is 4.5 amps maximum. We also have the integrated travel distance control. Feedback is the same, OCT, single turn or multi-turn encoders can be connected. And here you also will have the two additional inputs, the output for the brake, and one separate output input, which is called hardware enable input. With that, you can realize STO applications. Now we would like to start with a new product group. It's the AM8120 series. It's a compact integrated servo drive with the protection class IP65. The DC link voltage is the same as I showed you for the other terminals. It's from 8 up to 48 volts. Normally, and generally, you will use 24 volts or 48 volts. But for example, for some AGV applications where the power electronic will be, for that will be used the battery, for example, you also can run them with 12 volt, for example. The output current depends on the motor which you're using, so depending on the flank size. For the stack length, the output current goes up from 4 up to 8 amps. We also have this integrated travel distance control. We have an integrated feedback, multi-turn absolute encoder or single-turn absolute encoder, so you can order both of them. We also have some additional IOs on it. So you saw that are the black M8 connectors. There are two digital inputs and 24 volt power supply for these inputs. So there you can connect the input point to point and an integrated output for the motor brake. told you we have different stack lengths. We start with 3 different stack lengths. Stack length 1, it's 4 amp output current, 0.5 Newton meter at a rated speed of 3000 RPM. The second one is the stack length 2, which has 0.7 Newton meter at a rated speed of 4500 RPM. And the last one is 1.1 Newton meter at 3000 RPM. Here only to show you the order code, you can see, for example, how it's coded. We start with the USBs. It's made for applications without control cabinets. We have the direct integration into the Ethernet network. So on the green M8 connectors, you can connect directly Ethernet in and Ethernet out. So by using the daisy chain, you can go from one motor to the other. We have a high protection class, so IP65. We have the integrated power electronics for maximum 48 volts. There are also 2 additional inputs, which can be used, for example, as latch inputs or as limit switches. The integrated absolute feedback. And first time that we have it on this compact motion, we have the twin-safe STO via FSOE. So there is no hardware wire needed anymore for that. And the twin-safe logic is integrated. And you also can order it with an integrated holding brake. Further technical details are the electronic is plotted. That's for better terminal connection and safer regarding shock and vibration. Because in this case, if you use this kind of motor, the electronic is not longer anymore in a, let's say, safe area like a switch cabinet or control cabinet. It's mounted directly to the machine. The square dimensions are comparable to the standard AM8120 motors. We have approximately 5.5 centimeter longer than the standard motor. That means 4 centimeter is the housing and a little bit more than 1 centimeter extra for the M12 L-coded connector for the power supply. And the configuration is compatible with the established EL, EG, or EP solutions. That means that the resolution, for example, of the feedback is the same as if you use the combination of EL terminal and the AM motor. So you have, for example, 20-bit single turn and 12-bit multi-turn. So the configuration is 100% compatible, so you can exchange an EL existing solution with this AM without changing anything on your C configuration, for example. We have the power interface, which is an M12 connector, 5-pole, screwable, L-coded, which combines the 24 volts and the load voltage, so the power voltage. We have the intercat, daisy chain, that are 2 M8 connectors, 4-pole shielded and also screwable. And if we take a look a little bit deeper in the connections, the one is M12 L-coded, as I told you. The M8 connectors for the IOs are 500 milliampere current limited and usable as input. That means you have the input signal and 24 volts and ground for supplying this sensor. So it's a 3-pin connector. Or you can switch these sensor supply from the PLC program. So therefore you can use it also as an output if you want. And the 2 M8 connectors, the green ones, which you see on the, which are for Ethercat in and Ethercat out. The plugs are straight or angled. Now I would like to show you the startup. So you see it here, we scan the Ethercat. It will find the AM and automatically generate CNC configuration. The access will be also added automatically and linked to the AM8120. Will you name it here? Then you see it's linked automatically. After that, we added TwinCat Drive Manager 2 configuration. And immediately after clicking OK, the Drive Manager scans the configuration and find the AM. There you can decide which kind of DC link voltage you're using, 24 or 48 volts, and which kind of linear or rotary access. After pressing continue, say OK, that finalizes this configuration. And then you can configure everything. So at first you see all information about the connected motor, all technical data, all technical information about the brake, if it's connected, about the load and CNC scaling. And you can configure your digital inputs if you want to use it as a latch input, for example. You can configure the whole NC configuration from here. So all scaling can be changed here and saved directly to the NC. And you can tune the motor. That means that you can set up your position controller, velocity controller, and if needed, also the current controller directly from the Drive Manager. In this configuration, and also, sorry, you have the advanced tab where you can change everything, like, for example, the amplifier E²T, the warning level, and so on. Now we activate the configuration and start TwinCat into run mode. And then we let the motor run with the default settings. So for that, we set the position to 0, we enable the access, and then you can immediately start the motor. Fast velocity, for example, slow velocity, and also negative direction if you want. This is able because all necessary informations are directly stored in the electronic nameplate of this AMI. So without configuration, without configuring anything on the motor, you can start immediately. And in the same way, you can configure, for example, your safety configuration. As I told you, here you have safety SDO via FSOE. So therefore, we have here a small twin-safe configuration with 2 inputs, which are normally connected to an EL 9000 or 1904, for example. Then you can generate an output on this emergency stop function block. I call it here STO AMI, FSOE AMI. If I generate this variable at the output, I can link it directly to the STO functionality of this AM 8120. And that's all. Now we start with a new feature package for the existing and since many years in the market EL, EG, and EP modules. So new firmware, new features. The firmware version 20 supports the following new functions. Changing the operation mode on the fly. Brake can be closed manually for test purposes. Invert the direction of rotation of the motor. The new SIG IP core is supported. That means we can connect a motor with a safety encoder. We have the cogging compensation and the integrated travel distance control. We called it DMC. First, I would like to explain you the changing of the operation mode on the fly. That means you can switch between the operation modes CSV, CSP, and CST. That means velocity mode, position mode, or torque mode directly on the fly without reactivating the TwinCat configuration. The handling for that is 100% identical to all other back-off servo drives, like, for example, the X8000 or something like that. So if you made a project where you use this function, for example, for an EL terminal, you can use 100% identical software code to run that with the AX8000, for example. In the past, you had to do that manually. You have to change the predefined PDO assignment, and then you have to reactivate the TwinCAT configuration. And now you can handle it directly from the PLC. The other new function is the manual brake closing. Important is it's not a safety function. It's for predictive maintenance. That means you can close the brake during the normal run of the motor, and then you can measure your current or from the PLC and see how fast, for example, the current is increasing in that moment when you close the brake. So it's only for predictive maintenance, no safety function, really important. The next, of course, a small new function is you can invert the direction of the rotation. It's useful if you don't use our NC to control the servo terminal, or, for example, if you realize an gantry axis and you would like to have the wiring that stays the same for both motors. Now we come to a great new function. It's a cogging compensation. The cogging information of the motor is part of the electronic nameplate of the motor. So that means if you scan the motor by using TwinCAT, this information will be read out automatically by TwinCAT. And that ensures improved synchronous running properties, especially at low speed. This feature is switched off per default because we have to be 100% compatible to existing configurations. For that, I have an EtherCAT configuration with a servo motor terminal with an axis which is connected to that. I have a Drive Manager 2 configuration and a scope view where I would like to measure the actual velocity and the set velocity. Now I activate the configuration and we start the scope view. Now we go to the axis, enable the axis, and let the axis run with a continuous speed. Let's say in this example for 8 degrees per second, so really low speed. Then we go to the scope view. I restart it once to get a better resolution. And here you see you have a velocity ripple, which is around about 14 up to 15 degrees per second. So you see you have a set point of 80. Now we activate the cogging compensation on the fly. And then you see that the velocity ripple decrease by factor 10 roundabout. Also the way back. And you see again this really high velocity ripple. If we zoom in a little bit, you see that this is periodic, so it depends on the velocity. The frequency is the same, but it's really smaller than you see it. As you see it here, without the cogging compensation, we have approximately 20% velocity ripple, depending on the target speed. And with enabled cogging compensation, it's more or less only 2%. And now we make the same with a fast velocity. The same, we enable the axis. And instead of 80 degrees per second, now we run the axis with 2000 degrees per second. We also start the scope view. You see that the frequency is much more higher. And also the level is not so high. So we only have 4 degrees per second velocity ripple in that case. But if we enable the cogging compensation, It also will decrease by, let's say, more or less factor 3. You see it here. Now we have 2000 degrees per second target speed, and the velocity ripple without cogging compensation is 2004, let's say, degrees per second. So it's 4 degrees per second, and depending or regarding the target speed, it's only 0.2%. But it decreased by factor 3 in the same way if you enabled cogging compensation. The next big new function is the integrated travel distance control. So basic functions are supported, buffered mode is not supported. That means basic functions are point-to-point movements. Let's say you would like to drive from A to B with a fixed speed. Buffered mode, that means you drive from A to B, and during the movement, you decide the new target position. That is not possible because that's not supported. The I/O structure of the terminal can be linked directly into the PLC. That means you don't have to link each object one by one. You can do it in the same way as you know it from the NC. We have a Trinket 3 library comparable to the MC2 Lippe for the PLC. I will show you later. And it's the first time that you can run a servo motor terminal on, for example, small controllers like the CX7000. So controllers which don't support the DC, that means distributed clock functionality. Or you also can run it on non-backoff masters. For example, a Profinet master with a EK9300 in combination with these EL terminals. If you take a look at the function diagram, so you start, you take a look if the terminal is ready to enable, so no error, then you can write directly to the process data all important informations like velocity, acceleration, deceleration, target position, and so on. After executing the command, the terminal answers with the busy information. The busy goes to 0, so if you see the falling edge, normally you get the target information, and then you can start the next command. For that, in combination with Trinket 3, as I told you, you have a library. So you have the administration function blocks like MC Power, Reset, Touch Probe. You also can set the actual position, and you have the MC Home. The next block of function blocks are the motion FBs for the standard point-to-point movements. So you have a move absolute, move relative, but you have as well an MC jog for small movements, and as well MC modulo and a halt. At first, you have to add the library. For that, you go to the reference, add the library, you find it under I/O, drive, and then you can add the TC3 drive motion control. And with this library, you get the user-defined data type, so this access reference, to connect it, to link it to the terminal. And you have your administration functions like MC Power, Reset, Set Position, the Touch Probe functions, and the motion functions, MC Home, Jog, and the point-to-point motion. To commission that, you change the predefined PDO assignment of the terminal to drive motion profile. Then you see immediately that the process data changed. So all important or necessary information are now part of the process image. You can add these access reference in your PLC program. And then I will link it directly, the input and the output, to the terminal. When I activate the configuration, We start TwinCAD in run mode. After that, we log in the PLC. There first, we use the MC power, which is the same as the enable functionality of the MC. So we set it to true. And then in this example, I'm using the MC move relative. And here I also start with the execute. And then you see the motor running. So now we are close to the end of this webinar. We had two blocks. First was the AM 8120 series. Here is a short summary with the key facts. First, currently for flank size dimensions F2 is three stack lengths available. For applications without control cabinets, so the protection class is IP65. Standard connectors plug, M12L coded and M8 connectors. We have an integrated absolute encoder, depending on which you order, a multi-turn or single turn. And we have first time the possibility to have this with TwinSafe SDO via FSOE and including the integrated TwinSafe logic. The second block was the new feature package for the existing EL, EG, and EP servo solutions. The key facts are change operating mode on the fly, as I told you, without reactivating the configuration. The holding brake can be closed manually for predictive maintenance. We have the automatic cogging compensation. We have this integrated travel distance control to get this motor running without NC, for example. That's all for today. If you have questions regarding this webinar or some hints what we can make better or so, please send us to go to webinar@beckhoff.com. I will take a look if we have some questions. Marvin?
Availability of AMI.
One question was the availability of the AMI. You can order it. We are still delivering prototypes and the first released versions, but the version with TwinSafe SDO, the series is planned for the end of this year. Okay, then I say thank you. See you next time.